Example 8.2. A hanging flower basket having weight W2 23 Newton is hung over the edge of a balcony railing on a uniform horizontal beam. Length given is 110 that rests on the balcony railing. The basket is counterbalanced by a body weight W1. If the mass of the beam given 3 kg, calculate the weight 1 needed. P, the force exerted on the beam at point O. We need to find W1. First, what we need to do is find CG. To find CG is total length, which is 110 divided by 2. We will get 55 cm. 55 cm is from A to the center. And we assume center here. Then draw the weight of beam. This is our CG. Find the CG and then draw the weight of the beam. WB. To find weight 1, next what we need to do is draw simple or sketch simple forces that exerted on this diagram. Then we have here weight 1, weight 2, and then the beam is touched the railing balcony, means that here we have normal. Then sketch the free body diagram. We have here W2. Here is our normal, and then here is our weight 1. CG is at the center. Assume here is our W beam. Then the distance from the O to W1 is 0.35. Convert to meter. Distance from here to here is 0.2. And then distance from here to here given 0.75. Center of the beam here. Okay. First, find CG and draw the weight of the beam. Second one, this one is second one. Then draw free body diagram of the beam. After that, fourth one is pivot point. Pivot point to find the top. Pivot point. We use the condition total top is equal to 0 or total top AC equal to total top C. For pivot point, you can choose any point to be pivot point. For me, I choose at point O. Pivot at point O. Then, after pivot point, what you need to do is to find the perpendicular distance. Perpendicular distance to all the forces. For this one, N force is parallel to D. Means that here, for N, when we put pivot point at O, top at N is equal to 0. Okay, top at N is equal to 0. For force WB from axis of rotation to force WB, here we have perpendicular distance, and this is our dB. Okay, for force 1 from the axis of rotation to force 1, this is our perpendicular distance, this is D1. Okay, then another force W2 from the axis of rotation to D2, this is our perpendicular distance, which is D2. Then we know that top is equal to FD, which is top. F and D is perpendicular. When we use D, top and F and D must be perpendicular. 5, we need to find the direction. 5, direction of top of the forces. Rotate. Okay, for force 1, W1, when you pull the beam downward, from the axis of rotation here, pivot point here, means that this beam will rotate clockwise. Same goes to WB. When you pull downward, it will rotate clockwise. For W2 here, if you pull downward, means that it will rotate anti-clockwise. For beam 2. For W2, it will rotate anti-clockwise. Using total torque AC equal to total torque C, rearrange the equation. We have here torque 2, which is anti-clockwise. Just rearrange. No need to find the positive or negative anymore, because total torque AC is equal to total torque C is come from total torque equal to 0, which is total torque. We have only 2 torque. Total torque anti-clockwise, which is positive, minus, because total torque clockwise is negative, equal to 0. Total torque AC equal to total torque C. Then we don't need to identify the positive or negative torque already. Then just rearrange the torque. Rearrange by total torque AC. Here we have torque W2 D2. Here we have torque 2, and then dBWB we have torque B. Torque N is 0. Torque N is equal to 0 because at the axis of rotation, the force is at the axis of rotation. And then we have from axis of rotation to this point, another torque, which is torque 1. Okay, we have torque 1, torque 2, torque B. Then susun. Torque 2 is AC equal to total torque C. We have 2 torque for C clockwise. We have torque B plus torque 1. Then we know that torque 2 is W2 D2 equal to torque B is WB plus W1 D1. Substitute all the value. We have here W2 D2 equal to weight B given mass B. Mass B, weight B is mass BG dB plus W1 D1. Okay. Substitute given value 23 for Newton 2 or Newton for weight W2, and D2 given here from the axis of rotation to W2 is 0.35. Then 0.35 equal to M given 3 kilo times 9.81. dB is from axis of rotation to WB is 0.2. Then dB is 0.2 plus W1. Then D1 is length from axis of rotation to this force, means that 0.75, sorry. Then when you calculate W1, you will get W1 is equal to 2.89 Newton. For question B, the force exerted. Calculate the force exerted on the beam at point O. Point O is here, means that this question needs to be to find force N. We use first condition of a rigid body, which is total Fy equal to 0, because we just only have forces at y-axis. Then Fy, we have N minus W2 W2, WB and W1, which is negative direction. W2 minus WB minus W1 equal to 0. Then N is equal to W2 plus WB plus W1. W2 given 23 Newton plus beam, mass beam G plus W1 we just get from the first answer, which is 2. And then substitute all the value. Mass of beam is 3 times 9.81, then plus 2.89. We get N is equal to 55.3 Newton. That is normal force. And that is the force exerted on the beam at point O.